Good day, world. Here we have a technical editorial. This is an editorial for coders, and it comes from medium.com. The author is Xiaohui Liu. He is a leading edge innovator, and recently he released an article talking about the most transformative breakthrough for Bitcoin Ordinals. That is supporting smart contracts. And David Case, another of the biggest innovators at Sugar, says the possibilities are endless in response to reading this article. So here we have it. I'll read it to you. Integrate Ordinals with smart contracts on Bitcoin, Part 1. Lately, Bitcoin ordinals have garnered significant attention within the blockchain domain. One commonly alleged drawback of ordinals is its lack of support for smart contracts, compared to other token standards, such as the Ethereum's ERC-721. We show you how to add smart contract capabilities to ordinals, broadening the spectrum of its use cases. Contrary to popular belief, not only are ordinals compatible with smart contracts, they are actually perfectly suited for smart contracts. Ordinals plus sCrypt. As a showcase, we have developed a smart contract that enables permissioned ordinals. Compared to a regular permissionless ordinal, each transfer needs to be approved and co-signed by an issuer. Basic idea. Bitcoin uses a UTXO, unspent transaction output model. Each unspent transaction output consists of two fields. First, the value, the number of satoshis in this output. Second, the script, a Bitcoin script that locks the output. If the unspent transaction output is inscribed as a non-fungible token using one-sat ordinals, the value is 1 and the script controls how the token can be minted or transferred. Since they are in two separate fields, an ordinal token can be locked into any script. That means the token can be controlled by any smart contract. Mint. As we introduced before, ordinal inscriptions are minted in an envelope between opcodes opfalse, opif, and opendif. The inscription of the text "Hello World" read aloud sounds like this: opfalse, opif, oppush, ord. Op1, oppush, text plain, charset equals UTF-8. Op0, oppush, hello world, opendif. Opfalse ensures the inscription script never enters the opif branch, and it is never executed. The whole inscription can be regarded as a NOP code and combined with other script without changing its execution. NOP code is no operation, a machine language instruction and its assembly language mnemonic, a programming language statement or computer protocol command that does nothing. In the case of sCrypt, it is prepended to the locking script that compiles from sCrypt smart contract. It does not change the behavior of the contract and can thus be safely combined with any contract. Inscription script, locking script. Transfer. After the token is minted, its transfer is dictated by the smart contract, just like native Bitcoins. Each transfer can move the token or Satoshi coin into a new smart contract. Note, there is no preceding inscription script in ensuring transfers, only when it is first inscribed. Locking script. Permissioned ordinals. Most of ordinals today use pay-to-pub-key hash, P2PKH, as locking script. When Alice wants to transfer an ordinal to Bob, she does not need permission from any third party. There are cases where each transfer has to be approved by the issuer, for example, for legal compliance. When minting such an ordinal, we can use the following smart contract. Here we have a smart contract from GitHub, and reading aloud, it sounds like this. Export class, permissioned ordinal, extends smart contract, @prop, read-only issuer, pub key, length of inscription script, @prop, read-only inscription len, inscript len, big int, @prop true, owner, pub key, is being minted, @prop true, is mint, boolean, constructor, issuer, pub key, inscript len, big int, super, arguments, this dot issuer equals issuer, this dot inscript len equals inscript len, this dot owner equals issuer, this dot is mint equals true. @method, public transfer, recipient, pub key, owner sig, issuer sig, assert, this dot check sig, owner sig, this dot owner, owner signature check failed, issuer cosign, assert, this dot check sig, issuer sig, this dot issuer, issuer signature check failed. Save a local copy. Const is mint equals this dot is mint. This dot owner equals recipient. This dot is mint equals false. Let output byte string equals this dot build state output in one sat ordinal. If is mint, cut leading inscription script. Output equals slice, output, comma, this dot inscript len. Check outputs. Assert hash 256 output equals this dot ctx dot hash outputs, comma, hash outputs mismatch. Besides a signature from the current owner at line 26, which is a contract state at line 10, a signature from the issuer is also needed at line 28. Since the contract is stateful, each transfer must ensure the Satoshi is moved into the same contract, ensuring all subsequent transfers need issuer signature as well, not only the first transfer. Note, the leading inscription script is cut at the first transfer at line 39. Other potential use cases. The orthogonality of ordinal tokens and smart contracts means they are infinitely composable. There are numerous ways to combine them. We only list a few below. These examples are op-ns. Use ordinal inscriptions backed by mini proof of work to create a fair mint hierarchical naming system for the Bitcoin database. Atomic swap between ordinals and Bitcoins. Lock ordinals in an HLTC to allow trustless ordinal sales. Cap the supply. Currently, BSV20 allows minting even after max supply is exceeded. BSV20 is the fungible token standard based of 1-sat ordinals. Using contract, we can disallow such minting transactions on-chain instead of invalidating them off-chain at indexers. Another example is blacklisting or whitelisting. Another example is freezing and recovery. Now, there is another footnote here. It says, in fact, an inscription script can be inserted anywhere when the sCrypt smart contract is stateless. For example, it can be appended to the contract script, but appending does not work for stateful contracts. For it to work with any sCrypt contract, we put it at the very beginning as a convention. Yay! So that is the latest editorial from the innovator Xiaohui Liu. He is the developer of sCrypt and a leader in developing smart contracts on the Bitcoin blockchain. So, as Bitcoin continues to scale, we also continue to receive wonderful capabilities by the human ingenuity of participants in the ecosystem. To continue developing along with us, you can follow sCrypt on Medium for more innovative editorials written especially for developers. Now, I myself am not a developer in the coding sense, so let me know if it's useful for me to read aloud these developer cues, such as the inscription of the text or the GitHub smart contract text. If it's helpful, I'll continue to do so. But if not, then you can look it up yourself and just do it.